Hey, everybody. Welcome to Claims Corner. Thanks for joining us. I am David James, the Property Training Manager here at CNC.
And I'm Craig Fowler, Executive Vice President of Training and Quality Assurance
When
here
did
at
you get
CNC.
here? I didn't see you come in.
I showed about 3 minutes ago.
Oh, okay. Well, thanks for joining.
Yeah.
So we're into our fourth season, right?
Yes. Yeah, we are into our fourth season, second episode.
Mm-hmm.
You know, it's we talked about this on the last episode about being the fourth season, and it didn't really settle in until now that, this is our fourth year of doing this, and we've been doing this. We're bringing these speakers and bringing this information in and trying to get these topics out that I think were really beneficial for adjusters. Stuff that you normally think or you want to know more about, but you don't really have time to do it. And so we put these claims corner together. That was the sole purpose of this, to put this together and it has grown. I mean, we keep adding and keep growing and keep improving and making it even better. And it's crazy. It's funny. We're innovating. We're pushing this information out, and now I'm starting to see that there's a lot of people out there now. They're trying to duplicate it. We've done this 4 years,
Right.
and the stuff that we put out there is just great. I mean,
It's current.
it's current. It's informative.
It's up to date.
And it's things that
And it's needed. You and I talked about this before. Growing up, I was in sports most of my life. And
It doesn't really show now. I'm just gonna.
we'll have to talk off camera about that. But when we think about this, professional athletes or even athletes, I mean, you don't just get a schedule of your games and go to the game, right?
No.
I mean, some do, but the ones that actually practice and train, they perform better, right?
Off season, you're continuously training. If you're not continuously training, you're not going to get better. You're not going to improve. You're not going to be ready for that first game.
Right.
And that's kind of how claims are, in a sense. You're not ready for that first claim. If you're not paying attention and listening and learning new stuff like we're going to do here today in this Claims Corner episode, you're missing out. You're missing out. And that person next to you, that other athlete, if you want to call them that, is out there training. They're doing better. They're improving, and eventually they're going to take your spot.
And you know why? Because even though they may be experienced, they go back to the basics. Just like a baseball player. I was fortunate to be surrounded with a couple of folks that's been around for a long time. And during the off season, you know what they do? They go back to the basics.
Yeah.
They show up. The first thing they do is they hit off a tee. It's like, well, that's
T-ball.
T-ball. No. You're perfecting your skill, working on your mechanics and your knowledge and so forth. So anyway.
Yeah, so that's what we do here. That's what we're doing here with Claims Corner. And it's our last episode that we did was Dr. Hal Needham was on. He did that presentation on the 2022 Atlantic hurricane season, which we talked about. What was the expectations a little bit for the 2023 season? And I sent out that question. I asked him that question about it was almost like the seasons are getting later. The storms are showing up later. And so he started thinking about it a little more. So he emailed me about his response to this. And his basic reply was he feels like there is some of this actually out there where the storms are like 90% of them are happening at peak or after peak, even though the season's so long. And that's something that we never really looked at because everybody's focusing on the season and not realizing, okay, it's September. And I think he even said that it's kind of even pushed that it was September 1st, but now it's like September 10th is kind of like where the peak's kind of evolving. But he mentioned this. He's actually going to give us more insight on this at our conference that's coming up May 2nd and 4th.
Well, if you think about it, Sandy was when? Hurricane Sandy?
October.
Yeah.
Late October.
Yeah.
Halloween.
Mm-hmm. Yeah.
So, but yes, he's going to talk about that, more information about that at our conference.
Okay.
And
We're having a conference?
yeah, May 2nd through 4th. So,
Okay.
and anyway, he's going to talk about that at our conference. I think we have some really, really great presenters. We have some clients. They'll be there doing some certification classes. We'll be doing some certification classes as well. We're going to have CE credits. We're going to have our CNC points. We got some really dynamic speakers. They're going to talk about stuff, and including one of our speakers that's going to be there are our gentlemen that are on with us today.
Right.
So
Right.
if you haven't registered for a conference, highly recommend you do so. We got a lot of people that are getting in and registering, and it's still our early bird pricing right now, which is what? How much is it?
I'm scared to say, honestly. It's $99. $99.
For C credits, for CNC points, for networking, for
Certifications.
getting all this great apps.
All the information that
Certifications.
we're going to give away.
Yeah,
We're
all this
giving it away.
information.
Yeah.
Golf tournament,
Yes. The airboat ride.
airboat rides, little things like that.
Yes.
Yeah, that's a really
$99.
a good price for.
And all
okay,
the-
we
all
got to
the-
stop this
all
because
the
it's almost
people
like we're
that-
selling something and we're not.
No,
It's
but
like,
I'm just excited about the people that we're gonna
call
have
us right now for
speaking.
$99.99. You get it. Not only you get a claims, you get CNC, you get certifications, you get C credits, you get this now. But wait,
Hey,
there's more. There's a golf tournament. There's airboat rides. There's networking. So yeah, we got to stop that. All right.
Okay,
So let's
sorry.
get to our topic today because this is getting way out of hand.
like we said, it's, our second episode, right? So our topic is going to be HVAC surge and lightning claim-related damage and things going in that direction. So I think before we get into that, we need to go to Julie. Is that right? Just for some
don't know.
logistics.
Hey everyone, just to let you know, I'll be monitoring the comment box. It's in CNC Pro under where you're watching the video. And if you have any questions for Jay, put them in there and I will be happy to ask them for you. And I will see you at the end of the presentation.
Thanks, Julie. Like you said, we've got Jay Dykstra, Brian Estes here with us today. Brian's the account manager, and Jay is the technical education manager at Alpine Intel. Sorry about that. So I'm going to let you guys take it away from here.
Very good. Thank you very much, David. Thanks, Craig. We're excited to be here today. Thank you for having us on your claims corner. Really like your setup here, and we're excited to not only be here today, but also to be with you all in May for your conference for just $99. Let's just reiterate that really quickly.
But wait, there's more.
That's right. Bring Brian in. All right, so I'm only going to talk for 5 minutes or so. Jay is our resident professional trainer, and he's going to be speaking about HVAC claims and lightning and surge damage to HVAC equipment. But I just wanted to give you a little overview on our business. Just very quickly, I'll be in and out 5 minutes. So are the slides up, Jay? I don't see the slides.
I believe they are, yes.
Okay, there we go. All right, good.
There you go.
Okay, good. Yeah. So anyway, we at HVACi have been together for about 12 years. We realized that we really felt like there's an opportunity to disrupt the HVAC space, and so we inspect damaged HVAC equipment on behalf of adjusters. And we started StrikeCheck about 8 years ago, and that's where we look at appliances and electronics and those types of items. Just about a year ago, we merged with Donan Engineering. And at that point, we created a new brand by the name of Alpine Intel. And so HVACi, Donan, and StrikeCheck will all be under Alpine Intel. And they are. And I'm your representative at CNC. So excited to be here today. I want to give you a quick overview on HVACi. So at HVACi, we provide clarity to carriers on residential commercial claims. So I think a good way to look at it would be anything that heats or cools. So split systems, radiant heat, furnaces, boilers. Had a claim not long ago. It was a mixed-use facility, and there were a bunch of 5-ton units on the roof. There was a big chiller up there. There were some mini splits on the building, and even some refrigeration equipment in the restaurant. So that's kind of an example of the breadth, all in one claim, really. Wow. And we focus on being 100% objective. We are not trying to push the claims one way or the other. Speed is very important to us. We want to give you real-time actionable reports with real-time pricing and information availability, and then education. That's what we're here to do today, and that's what we're going to do in May when we're down in Mobile. So with us, you can engage us 2 different ways. The first way would be to have us do an on-site inspection. About 95% of the assessments that we receive are on-site inspections. And with that, we are determining when we're inspecting these HVAC equipment, we're determining causal loss, making a repair replacement recommendation, providing pricing, which would be like light, kind, and quality pricing, as well as ACV and RCV pricing. And then we can, about 5% of the claims that we receive are desk reviews. You're not concerned about the cause there. You're not concerned about the scope. You just want to verify pricing and availability of parts and components, and we can do that. And speaking of cycle times, we can turn those around in very short order, about a day. So that's HVACi. Then, as I mentioned, about 8 years ago, we started StrikeCheck. All right, the name here implies that it's a lightning or surge business only, but that is not the case. It's any peril, just like HVACi. Smoke, fire, water, freezing, damage, whatever it might be, any peril, just like HVACi. Good example would be the Texas freeze that everybody's very familiar with, February 16th, 2021. Pipes burst in all these homes, these businesses, damaged electronics, appliances, and those types. So same thing as HVACi, causal loss, repair, replacement, recommendation, pricing, ACV, RCV, light, kind, and quality, et cetera. Okay, so HVACi, there probably aren't a ton of other companies who are doing what we do, but StrikeCheck, maybe there are a couple, but I'm gonna tell you one of the differentiators for us would be the breadth of the types of items. So the Texas freeze, as an example, one of the many types of items we got involved in were these pool motors that froze, the pool heaters, hot tub heaters, motors, those types, but also generators, well pumps, electrical panels, and of course, all the appliances and electronics. And also on the commercial side as well. And then we have engineering. All right, so Donan Engineering has been in business since the 50s, and we are really excited to bring them together with us. We believe that there's a lot of synergy between our businesses. So civil and structural engineering, which includes, the roofing investigations, mechanical engineering, there's a lot of synergy there too. Let's say the adjuster's really looking to determine cause and origin. Well, our techs at HVACi might not be able to do that, but we certainly can engage engineers at Donan to do that. And then electrical engineering as well. Let's say, StrikeCheck's called out, we're looking at a panel or maybe the whole home electrical, whole business, and then realize that really this is a little bit more complex. We need to bring an electrical engineer in. So certainly some good synergy there. And it goes the other way too. Maybe you call Donan for, thinking you need a mechanical engineer, you might just need us to send out a tech through HVACi, or same with an electrician as opposed to an electrical engineer. And then one of the big things we're really excited about are these fire investigations that Donan offers. We can do them all over the country. We have all these certified fire investigators. Explosion investigators can get in some of these auto claims like the ASE Master Certified. And one of the really, really cool aspects that will be included in these fire investigations are these Matterport 3D scans. In fact, I was presenting to a carrier earlier this week, and they thought, man, I really would just like to have the scans. I don't need to always determine cause or investigate, but I really do need the scan. So could you provide a limited report? And the answer to that is absolutely yes. So anyway, that's a mouthful. That's a lot in 5 minutes, but I'm going to pass it to Jay Dykstra. He is our trainer, used to be a field adjuster for a large company, and then has been with us, and then moved into their claims university and has been with us for several years since. So we're lucky to have him. So Jay, I'll give it to you, and I'll be available for questions at the end.
All right, Brian, thank you so much. I appreciate that, and I appreciate everybody that's on the line with us today. My background as an adjuster really, I think, helps lend to the way I'm going to have a conversation with you today. And because I'm going to think like an adjuster, I'm going to talk like an adjuster. Not that it's not going to be technical, but when I wake up every day, I kind of feel like an adjuster. So I love to help adjusters. So send your questions over. We're going to save some time at the end to talk about it. And like claims, I'm going to move very quick. We have a lot of stuff to get through, and I want to give you some good takeaways. So let's talk about lightning and surge HVAC equipment. We were joking around earlier about what is HVAC. And I mean, sometimes you might think that's too basic, but heating, ventilation, and air conditioning. So sometimes, and a lot of times they put an R on that as well for refrigeration. So let's talk about lightning basics. And again, this is probably review. But when storm clouds build, they become electrically charged, okay? And believe it or not, the tops become positively charged, the bottoms become negatively charged, and the earth underneath these building cumulonimbus clouds become positively charged. So you know what lightning is? It's like a giant static event, like walking across the carpet and touching the light switch and getting shocked. It's really just trying to equalize that imbalance between the clouds and the earth. The problem is they can cause a lot of damage because it's a lot of voltage, up to 1 billion volts of energy. There's lots of different types of lightning. You might not have thought about it. There's intra-cloud, within one cloud. There's cloud to cloud, the negative of one cloud going to the positive of a negative, the negative of the other. And then there's cloud to ground. That's only about 20% of the time. So all those other lightnings still create a light show, still create a lot of thunder. So it feels like, even if it's right over your house, that your house got hit by lightning, but it probably didn't. Only 10 to 20% of the time does it actually hit the ground. This is my favorite lightning picture of all time. This was taken by Kyle Allen in Lubbock, Texas, a couple years ago. And cloud to ground lightning can actually go from the bottom up, believe it or not. A lot of lightning starts at both and meets in the middle, but it happens so fast your eye doesn't pick it up. But look at that lightning. It looks like a tree, and then there's a tree in the picture that looks just like it. I love that one. So ground strikes, let's talk about that. These are all parts of cloud to ground lightning. These are the ones we're concerned with because these are the ones that can cause damage. They are going to leave visual damage. If it's near a house, they can come into our houses through pipes and wires that are underground. Tree strikes, same thing. They hit the tree, might burn up the tree, might explode the tree, might peel off the bark like this very dramatic photo. Then the energy's in the ground. Then it gets picked up in pipes and wires again and comes into our homes. Utility strikes. This is one where I think people get a little confused on. It's not likely lightning's going to hit wires or transformers and come into one house, all right? Never say never, never say always with lightning. But normally this would be evidenced by a widespread outage, okay? So if you're, as an adjuster, ask the insured, did your neighbors have issues? Was the neighborhood out? Did all the power go out? Things like that. That's going to lead you to a different determination probably than just saying, hey, the lightning must have hit the wires and it must have come into my house. That's probably not necessarily what happened. Direct strikes, things do get hit by lightning, not as much as we think, but we remember these as adjusters because those are the dramatic claims, good pictures, lots of damage, and things like that. So that's a high level, very quick overview of lightning, but now let's compare and contrast that with high voltage surge. So a surge is any sudden increase in an electrical system, all right? So it's not one thing, all right? It can be different sizes of energy and stuff like that. But the key to remember is it's in the electrical system, meaning wires. You're really not going to have surge damage or surge jumping around in your home like maybe lightning would. Lightning can jump from a building product to a wire and even do other things as well. Surge is going to be in an electrical system, so things that are connected by wires. One thing you got to be careful about is don't jump to conclusions and don't back into your claims. All right, look at this picture. That picture could be surge damage. That picture could be lightning damage. All right, so you have to know more about it. You really have to have a trusted partner out there to help you with measured testing and other things to look at to find out whether that actually was lightning or whether that's just a surge damage. May or may not depend. We don't get involved in coverage, but it may or may not depend on coverage depending on what the policy says. You might need to be very specific on what it was. The tricky part is surges and some even lightning, but not as much, is surges a lot of times not visible, right? If you can't pull out an ohm meter and test these motors and circuits and things like that, you're guessing, right? And that's the last thing you want to do as an adjuster is guess on what's going on, or take somebody else's word for it that may have an another motive there on selling a new system with a new warranty or something like that. So lightning and surge both travel when they get into the wires, travel through the wires. Sometimes they move freely, they move right along until they can't go any further. Like motors, that's the end point. Switches, things like that, those are endpoints, outlets. Then it causes the damage. So if it's inside of a motor, you can't see it. You need to know what's happening and needs to be measured testing to figure that out. So surges are caused by nearby lightning. I talked about that, widespread outage in a neighborhood, things like that. It's a giant static event. High power devices. You can have surge damage in your home caused by other things connected to your home. Things that have big motors that cycle on and off, right? HVAC equipment's a good example of that with the compressors in that condenser. It could be the condenser in your refrigerator. It could be other large things in your home that are cycling on and off. The power grid is a big part of surges, all right? Whether it is substation grid switching. Sometimes they're just switching where the energy is coming from and going to. That can cause surges in the system. But probably the biggest and most notable one is when the power goes out and then comes back on. All right. If you think about that, you think about people have always told you, hey, when the power goes out, go around your house and turn everything off. That's probably the best advice ever for a power outage, because when it comes back on is when you're going to get surges through the lines and can cause a lot of damage in our homes. Okay. I know that was quick, but I want to get to the meat and potatoes of this, and that's the HVAC specific questions. So we're going to talk about split systems and package units. Both of those could be on a residential or a commercial claim. This is straightforward. I'm going to go through this quickly. Lightning, a direct strike, meaning it got hit by lightning, pretty likely it's going to be outdoors. All right, there's a one or twice a year it gets hit. Things, they go inside through a roof deck or something like that. But the cabinet, the fan motor, it's right up there on top. The condenser coil, which wraps 3/4 the way around this unit, is certainly a target, and it's good conducting metal, aluminum and copper. The disconnect, it's up on the side of the wall. It's a small target, but it could get hit just because it's outside. What about the things that can get affected by surge? Well, what did I say? It needs to be something connected by wires. So what are those items? The compressor, probably the most expensive, most important part, hermetically sealed. Can't see the damage in there. Going to have it tested to see what happened. The capacitor and the contactor, both electrical pieces of equipment, could be affected by surge damage. The disconnect, but from the inside out. The wires on the inside of the disconnect might be affected by surge damage. And then the fan motor, again, it's another motor. It may get affected by surge and lightning. You can't see it. You're going to have it tested. So what about the unit that's inside? That's either the furnace or the air handler. And there's not quite as many things. Like I said, it's not likely it gets hit directly by lightning, although if I have time, I'm going to show you some dramatic photos of the once or twice a year it does happen. Thermostat, low voltage device, very expensive nowadays. Smart home, Wi-Fi enabled, digital display, control boards in it. Watch out for those thermostats getting damaged on any level of surge, being just 24 volts. Furnace control board, like any control board, think motherboard in your computer. It does not take much to damage a control board in a furnace or air handler. The blower motor is the same story. It's another motor. It's an endpoint, certainly a target for surge damage. If it's a furnace, you may have a draft inducer or a gas valve. Again, draft inducer is a motor bringing in fresh air for combustion and expelling combustion gases. And a gas valve is a low voltage device on most systems that's controlling the flow of natural gas. It's a safety device. Again, very sensitive to any surge damage. All right, so here is a package unit. And again, we're going to have a lot of experienced adjusters on here, but just in case we have some newer folks out there, we call it a package unit because you took all the components we just talked about on a split system and we packaged them together. How simple is that, right? So now all the equipment's outside. All right, it's inside a case, but it's outside. It's either next to a home, on top of the roof, or on top of a commercial roof. So all those same things can get hit by a lightning strike. You know, the cabinet, the fan, big package units could have multiple fans. The condenser coil, and then the disconnect number 4 there in that separate picture. They're usually on a commercial setting attached right to the side of the package unit. Now, what are all those things that have wires in them? All the same things we just talked about, right? The compressor, the blower, the fan. If it's a furnace, not all package units are furnaces. When it is, a lot of times they call that a gas pack because it's working off natural gas. You could have a gas valve and draft inducer. In this picture, the disconnect's not shown. Something else a package unit could be that you don't think about all the time is a heat pump, right? So you wouldn't have all this gas and heat exchangers and burners in there. It would be a heat pump. You'd have reversing valves and some other stuff in there, maybe some heat strips, electric heat strips, and things like that. So don't forget these package units could also be heat pumps, or they could just be straight cool and used for air conditioning only. Quick overview of HVAC equipment. Now let's get into diagnosing lightning and surge. This is why you're all here today. The other stuff was good refresher information and bring you up to speed on the equipment we're talking about. Now let's talk about the cause of loss, which we're focusing on today. And that's why I rushed a little bit to get to here. Confirmed lightning, okay, has some very common characteristics. Okay, when something gets hit, it's probably going to have visual evidence. All right, we might have a lightning report too that says that we have lightning in that area. Okay, so when everybody's saying they have lightning, start asking. Do you have any visual evidence? Was a tree hit? Was the ground hit? Was your house hit? Was your equipment hit? Like this picture. So can condensers get hit? There's a very good picture that says yes, they certainly can. So it's going to leave that visual evidence that I talked about. That's very dramatic, right? Here's one that we looked at and notice where this unit is. It's in a contractor shop because it was already replaced by the time the claim comes in, which, as we all know, people do not wait to get their air conditioning going again or their heat. They're either hot or cold and they move on. So look at, if you're walking around this is our tech walking around this one, and they claimed it was lightning, right? You got to be pretty detailed in your investigation because you probably don't see it. I wouldn't see it unless I know where I was supposed to look. That's where you're supposed to look. Can you tell? That looks like a screw that's supposed to hold on the fan guard, right? It's not. I like to say as an adjuster, if you're not bending over, getting on your hands and knees and touching things and looking closely, you're not doing your job thorough enough. It'd be very easy to miss this. That little mark, the size of a dime, is a lightning strike. Don't judge lightning by the size of the visual strike. The one that had the blown up corner actually had less damage to the electronics than this one did. All right. Please, with lightning, all bets are off. Don't do that. Right. This one hit the cabinet, jumped down about 6 to 8 inches, and hit the reversing valve. This is a heat pump. Heat pumps have reversing valves. Reversing valves have low voltage solenoids in them to change it to be from air conditioning mode to heat pump mode. Look how much energy jumped down through free space, right? Melted that solenoid and opened up that refrigerant line. See the hole in that copper line? All the refrigerant leaked out as well. Okay. Solenoids are connected by low voltage wires. The wires now get into the system and go other places. All right. And they cause lots of other damages. When that energy travels inside, we would expect it to leave like a trail of evidence. All right. With lightning. Surge, maybe not so much until it gets to an endpoint. Lightning, maybe there's a couple different ways you could look for it. One would be arcing. Again, so much energy in lightning. It's got to end somewhere. It's got to dissipate. It's got to do something. And when it does, it usually leaves visual evidence more so than surge. Surge still can, but lightning more so. So if you see arcing marks and multiple arcing marks, especially on multiple components, that's a pretty good indicator if you're trying to diagnose lightning. Then we have this very unique signature here called ghosting. Not everybody has seen this, but this is a very specific, and you almost always know you're looking at lightning if you see ghosting. So let me explain what's happening here. We have a piece of this EMT, electrometallic tubing, which is conduit. It's metal. It's coming. It's got wires in it. There's a white wire, yellow wire, orange wire. I wish we would have opened this up and shown you. The lightning wasn't traveling in the wires. The lightning's physically traveling through the metal conduit. All right. Again, surge will not do that. Surge will be in the wires. So what's happening is it's traveling through this conduit. It gets to that, if it's coming, from the left here and it's making that left hand 90-degree bend, there was a small gap between the conduit and that metal plate on the equipment. When the lightning energy tried to jump that gap, the term they call it is ghosting. It ghosted out. If you would have been standing there, you would have seen a little flash and a little poof, and that would have been the energy kind of going into the air, right? So if you see ghosting, which is usually between metal products or where metal ends into something else, you're pretty confident you're looking at lightning damage there. I would try to validate other things on property and things like that, but pretty likely you're talking about lightning if you're seeing ghosting. So that's hopefully maybe that's a new term for you today. All right, that's lightning, some high level items to look for. Now let's look at high voltage surge. So surge is not as likely to be visible. Okay, it may be visible, but not as likely. So here we're looking at some wires. On the left is the capacitor. The capacitor is a small battery pack. okay, can be very likely affected by a surge event. The middle is the contactor. Contactor has high voltage wires and low voltage wires. We often call that the electrical crossroads of the unit. And then on the right, we just have a wire bundle, right? There could be other things out there. There could be little control boards and things like that. Um, Either of those things, then wires could be damaged, but we might not see it without testing. This is a perfect example. This is a compressor. It looks relatively new. It's in good shape. It's being well maintained. Um, and you wouldn't know as an adjuster with that picture whether it was damaged or not. Well, it turns out that one was damaged. All right. That one was affected by a surge event. So you definitely have to have that tested. So, with my hat on as an adjuster, something we should all be thinking about every day is repair versus replace, right? These are modular devices, right? Or components or systems designed to be repaired. If the compressor gets zapped by surge or lightning, you don't get a new system, even though maybe that's what's being requested. You don't even have to get a new condenser. You get a new compressor, and they can put a new compressor in. It's 4 bolts there, a couple wires, and two copper tubes. A technician can do that pretty effectively and efficiently. So think repair versus replace. If you end up utilizing our service, I think you'll be surprised how many times you see on our reports that we're replacing just the compressors that are damaged in lightning and surge claims. Okay, um, that's when they're physically damaged by lightning or surge. These systems are failing all the time for other reasons, including wear and tear, mechanical breakdown, bad refrigerants, contaminated refrigerants, and things like that. And then, of course, it needs to be replaced. It's just probably not a covered loss. Here's again where you have your hands tied as an adjuster. All right. So, what you're looking at here is a compressor being tested. All right. They got their own meter out, they got it attached to it. They have the red wire on the positive of the terminal going to the compressor, and then they have it grounded. They have it set the proper way. They're getting this reading on their screen which is telling the technician a current is being allowed to go from the motor to ground. And if you haven't heard that term before, it's called shorted to ground, which is basically short circuited or shorted out, right? You've heard those terms, right? That is not supposed to be happening. The energy is not supposed to be going from the terminal and it be able to go to ground. Something inside this motor now is touching that shouldn't be. The windings are touching each other, or the windings are touching the metal case. Something's going on, and we've had a major event inside this thing to make that happen, to let that happen. And now the technician has to go to the next step and figure out, well, was that an electrical event? Was that a lightning event? Was that a mechanical breakdown? Was that something else? Right. And let me tell you about a few other things that are either portrayed as or misidentified as lightning or surge. Okay. And these are things that are showing up all the time in claims, and you're going to want to be on the lookout for these types of things. The first one is resistive heating. If you have not heard that term before, basically what it means is when electricity is traveling or flowing through the wires, if you resist it, means slowing it down, it gets hot or hotter, right? It can be red hot, literally red hot. So when something's going on in the system and that's resisting the flow of electricity, it heats up. When it heats up, it causes damage. So resistive heating happens over a period of time, not sudden and accidental. Those all should be terms that are resonating with you as far as whether you're covering this or not, right? So let's look at some resistive heating. These are the terminals of a compressor, right? Look at that white wire on the left, good condition, no problems, right? So resistive heating can be caused by rust and corrosion. That's slowing down the flow of electricity. Look at those other two wires. The one in the middle also has a bad connection, and the one on the right, it's all rusty, right? So which came first, right? The rust or the corrosion? It was rusty. Then we've had resistive heating. If it's within 1 to 2 inches of a connection and the connection's rusty, um, that is not lightning and that is not surge. That is resistive heating. All right. So look how many times those wires, every time it cycled on and off, they got hotter and cooler, hotter and cooler. It actually melted the insulation around the wire, and it finally failed. All right. I like this picture because it's got a good story in there that maybe you'll learn something new on this one. So, two different kinds of terminals. Some of them have the screw-in connections. The other ones have pins. They physically push in their pins. There's 3 of them, right? The top right one has failed and broke all the way off. We had a little, little flame event at that time, and it kind of made it all black and charred in there, right? The bottom wire wasn't far behind it. You see there's rust going on there. You see the wire insulation receding. It's actually melting away from resistive heating. Eventually that one was going to fail as well. You see that third wire? It's a newer looking wire. It's kind of connected to that 5 or 6 sided funny looking block thing there. Does anybody recognize what that is? If you haven't been in this business before, you probably would not know. That is called a terminal repair kit. So what's that tell you? That tells you this happened in the past, folks. This has already happened in the past. Something happened. We didn't have a little fire there, and the wire failed. The technician came out and did what they were asked to do. Fix my system and get it going, not give me a new system, right? Because you would do the same as me, I'm guessing. My system stops working today. I call my tech and I say, can you come out and fix it? I don't say, come out and give me a quote for $12,000 for a new one. So this happened in the past. They fixed it. I'm sure the tech probably said, this is going to happen again in the future. I don't care. I only have money today to fix it. Get it going. I'll deal with it next time. And this is the next time, right? Resistive heating, not sudden and accidental. All right, let's keep moving. Here's another one, loose connections. Same thing. Electricity is being slowed down by the loose connection. See that wire that's deforming there and receding, melting 1 to 2 inches within a connection, loose or rusty. This one's actually rusty too, rusty and loose. Not lightning, not surge. If that was a good connection, lightning more likely would, or surge, would flow right through it. It wouldn't know to stop there and cause damage. It causes damage when it can't go any further, like endpoints, like motors. All right, that's resistive heating. What about acidic refrigerant? All right, so what this person is doing here, this is a technician. They're opening the service valve. They started with a little acrylic tube that had yellow, yellow pH paper in it. They ran a little bit of refrigerant over it. If it changes colors, there's acid in it. All right, that's the same pH type test you would do for your soil out in your garden and to know whether it's neutral soil or whether it's acidic soil. Okay, we can't have any contaminants in the refrigerant. Okay, if we do, it becomes acidic and then the compressor fails. All right, that does not happen sudden and accidentally. That happens over time, and that is not caused by lightning or surge. All right, so if you have acidic refrigerant that has frozen up or burned up your compressor, and someone says, well, that lightning was so bad or that lightning was so hot, it turned the refrigerant into acid. I'm here to tell you that's can't happen. That doesn't happen that way. All right. Acidic refrigerant is from contaminants that happens over time. All right. Dirty coils. So this is good to know about claims. This is a very good thing to know anecdotally for your house. See how dirty that coil is there? Could go with the inside as well. Look at that evaporator coil. Dirty. So what's happening and why is that bad? Okay, so if you've taken our fundamentals class, which I think I did last year here at Claims Corner, we talked about we have to have the flow of air through the coils, both coils, the outside coil and the inside coil. That's where we're transferring heat. Remember, folks, these systems are not generating cold air. We're moving heat from the inside to the outside in cooling mode. And we're doing that with the refrigerant, but that means the air has to touch these coils so we can get the heat out of the air into the refrigerant and then move it to the outside. Okay. If they're dirty like this, the air can't touch the coil. It's like having a blanket on you. You want to stay a little warmer, you put a blanket on you so the cold air doesn't touch you, right? It's the same concept, right? If you have dirty coils, the air doesn't touch the coils. We don't get that transfer of heat. And we don't get the transfer of heat, the compressor works overtime trying to make it work, or the refrigerant's not changing state readily. It's supposed to be changing from a gas to a gas to a liquid as it's absorbing or giving up heat. And you have this thing called liquid slugging of your compressor. And you burn up your compressor because you have dirty coils. Okay. So anecdotally, make sure your coils are clean at home. On the inside, you keep them clean by changing the filter. On the outside, you can just rinse them off with a hose. Do not ever use a pressure washer on them. You will fold the coils over and probably ruin your coil. So make sure you're very careful on that. And if possible, spray from the inside out. Spray from the outside in, you just push the dirt further in. So there, I'm helping you with some home maintenance items, but don't be surprised on a claim that the system's not working. They're claiming lightning or surge, and it's really just a dirty system. Hasn't been maintained, and over time, it burned up because of that. Let's bring all this together with a few quick claim scenarios, and then I'm dying to see what kind of questions you guys have out there. And I know I went through this quick, but we're getting some good quick hits today. So let's look at our first one. We have claimed lightning to the equipment. We actually have two kind of mirrored systems. Not uncommon, maybe a big house left, right, maybe 2 stories up, down. We got 2 systems that are basically identical in this case. We need to go investigate them and investigate both of them. So these are all on-site investigations by HVAC investigators. And we're gonna test the electrical components. So these are newer systems. Look at them, nice and clean and neat and organized. And so we're gonna test the electrical equipment on the outside of, I think this is system 1, right? We'll call them system 1, system 2, system 1. And it's connected to an air handler in part of the attic. And this air handler looked like this. It's in good shape. Opened it up, looked at the components inside, the blower motor, that had its own little disconnect breaker on there. It's got a control board, all looks good. But the thermostat's all blackened out on system 1. Remember, low voltage device. So now we have the first thing we identified is thermostat on system 1 is not responding. Open it up, test it. Again, something adjusters can't really do. We have surge damage to this thermostat. System 2, we're looking at it. Well, first thing that happens is we open it up to check the electronics, and we see this big arc mark. Remember we were talking about arcing? And this is on something that's not connected directly to a wire. So we had some big energy here, right? If you put this panel back where it would go, look what's right there. So there's the screw that's holding it together. There's a ground wire right there. Okay, and these systems are grounded within themselves, and they're also grounded to the ground. All right, so it's a pathway for energy. There was lots of energy there. Okay, we got this big arcing. We go in the other part of the attic to look at system 2, and this is what we see. This is a little bit after the fact. That was a hole in the roof. All right, and they needed to cut it out, so they cut it out with a circular saw probably. That's why it looks like it's they didn't have a jigsaw. They used a circular saw. That's why they had to plunge cut it. That's why it looks like kind of a 6-sided figure there. Lightning came through it actually didn't come through the roof deck. It hit the roof deck right about there. And look what's right below that. It's hard to see there. There's a chain hanging. Well, there was another chain nearby. The lightning came through the roof, again, building products, down the chain, and basically blew up. Can you imagine how exciting that would have been if you were at home at this time? Look what that chain looked like. Melted all the links to the chain. That's how much energy. That's not surge. That's definitely lightning. Got some fried wires as well. So you guys know the outcome on this one, right? We're going to replace thermostat on system 1 and the entire system 2 because now we have air handler damage in the attic. We have wire damage. It traveled all the way through the wires back outside to that condenser outside as well. So system 2, but it wasn't both systems. So again, it could have easily been turned in as like both systems got hit by lightning, showing you just a few dramatic photos. All right, let's move on. I got a couple minutes left. I think I can get through these other ones a little quicker than that one. Here we got another system. This is looking at the terminals of the compressor, and see that white bubbly stuff? That's refrigerant and refrigerant oil. So we've had a big electrical event inside this compressor. Okay. The seal around those are made of glass and they melt at about 470 degrees. So we know we've had a big event. So something's going on. We need more information. Transformer is damaged. We have arcing damage on the control board. We're looking inside here at the furnace, and the furnace is looking good. There's nothing really going on with the furnace. So, but we have all that damage on the outside equipment. Here is the data plate. You see anything on there that looks interesting? Manufactured in May of 01. Say this is not a brand new system. Operating on R22. And I bring that up because that would scare a lot of people. They're like, look at this, old R22 system, damaged, illegal, can't move on, right? Look what our report says. We're going to repair this system. 2001 R22 system, and we're going to put in a transformer, a fuse, a control board, and a compressor, including the contactor and capacitor, which are called start components. We have the part numbers, we know the price. You can see we can get the refrigerant and that R22 compressor for a 2001 unit. So perfect proof right there. It can be done. We do it all the time. Don't be talked into that. You're not going to repair a unit that's R22 that is that old. Not true. If it can be repaired and everything's available, they may not want to. That's not what the policy owes for, though. So good takeaway on that one, I hope. Here's another one. Notice the trend. Everybody's saying lightning, right? So here's another one as lightning. This is a high efficiency furnace on the inside, and you can tell it's high efficiency, giving you a little side takeaways here because it has PVC pipes. One's an intake and one's an exhaust. High efficiency means it's using, it's so well constructed that most of the fumes going out don't have any heat in them. We're capturing most of the heat and going to the house. It's very efficient. So we can do it with a plastic pipe. So if you see a plastic exhaust flue, you know you're dealing with high efficiency. And the reason you need to know that, it costs more to fix or to replace. So make sure you know whether it's high efficiency. So there is one of those draft inducer motors. See the gas valve there, low voltage again, testing all that stuff out. In this case, it looks okay. No damage to the high efficiency furnace. We get to the unit outside. It looks like this. We open up the electronic compartment. It's probably average condition. A couple capacitors there, the contactor, the wires, some cobwebs, things like that. But as we get over into the main compartment, that's the compressor. Not looking great. There's the fan, looking even worse. There's the case sitting outside. We took the back part of it off to work on it. Look what that is. What do we say about that? That's the coil. It didn't get like that overnight, right? It's been like that for a long time. That's the part facing the house. Has not been maintained at all. Guess what? That compressor, when we tested it, shorted to ground, which means there was something going on, right? In this particular case, we deem that as wear and tear. It wasn't lightning. There was no lightning data. There was no surge. There was no other evidence of any other electrical event, but the compressor had seized up and failed because of the dirty coils. Liquid slugging. It was trying to work, but the coil was so dirty it couldn't. And over time, it just it failed. So that happens all the time. They get turned in as claims all the time. Be careful, even if there's, they picked a data loss that had a thunderstorm that day. Be careful on those. One last one, and then we'll see what kind of questions we have out there. So another one turned in as lightning, on-site investigation. Here we're looking at some of the wiring and some of the transformer there. We got a control board, more wiring. And now we're getting to the unit on the outside. That was on the inside. And no damage in there. And there's no lightning data on this one. There's no on-site lightning strike. There's no evidence of any of that. So now we're looking at the outside. There's another control board, the wiring harnesses and wiring bundles and the capacitor. Then we have the compressor again. Can't see anything on it. Looks okay, right? but we're testing it and it is shorted to ground. All right, so now we have to go on to the next steps. Shorted to ground, now we got to figure out what else is going on. So we check all the coils. The coils in this case look good. All right, the coils on the inside were clean. The coils on the outside were clean. So we know it's not that same issue we just had on the last one, right? What's the next step? Next step is that acid test. I described it to you before, and I'm going to show you. You pull out the new acid test, it's yellow, like this. The technician opens up the little service valve. They plug it on there, run just a little bit of refrigerant over it. If it changes color at all, which could be off yellow, little orange, orange brown, red, even pink and purple, those are really bad, right? It doesn't matter which color changes. If it changes even a little bit, it's got acid in the refrigerant. Acid in the refrigerant is not sudden accidental. Acid in the refrigerant will cause the compressor to stop working over time. And so our report on this one says wear and tear related compressor failure due to acidic refrigerant from contaminants. Might have been from a refrigerant leak, might have been from a bad technician working and mixing refrigerants, things like that. So just goes to show you out there how many times this does happen. We didn't get a chance to show you our statistics at the beginning, but a lot of times we show a statistic that says, over 20% of claims come in as lightning. Less than 1% of them end up being lightning. And I know you guys are probably seeing the same. Lightning is an easy one to point the finger at. With HVAC equipment, that's not usually the true cause of loss. So make sure you're getting some help out there. If you like our education, I certainly hope you do. Hopefully to see you at the conference as well. I'm going to be there, and I'm very honored to be asked to come and speak. But we also do our webinar series as well. And we're going to do some fundamentals, some HVAC 101. So some of the stuff I wasn't able to get into today in any detail. And if you missed it last year when we did it here at Claims Corner, we're going to do it as an open webinar on Wednesday, April 12th at 2 o'clock. So I'm going to turn it back over, and I think maybe it's going to be Julie who's going to see if we have any questions out there I can attempt to answer for you.
Julie, are you with us?
She may not be with us.
Okay.
Which is
Anything
fine
in the chat?
because I think she's looking at the chat to see if there's any questions out there. But I think we do have a few comments that.
I have a ton of takeaways.
Okay. Well, takeaways like to end it or to.
No, I learned some things.
I think there's a couple things that I learned too, and there's one thing that you're showing the data plate.
Mm-hmm.
Now that seems to be an area, just that data plate, the information, showing the R22, the manufacturer date, that information seems to be misread a lot of times by adjusters. And I don't know if y'all have a presentation just about how to identify the tonnage, the capacity, just looking at that model number. We're, especially on the flood side, we're going out there and somebody's doing an assessment on the claim, looking at the damages, and they're writing that make model number down, and then somebody comes back along and says, you estimated this as a 2-ton, and it's actually a 4-ton, and they're like, here's the model number. And it's amazing that I know there's a lot that goes into it. The manufacturer, and all that information is really. If you ever have anything like that, please let us know, because I think that'd be another good presentation to have, or just one of your webinars that y'all do, is to be able to see this and understand what a lot of this really means for an adjuster who's out there, which gives them that extra information so they can actually educate the policyholder as well in a lot of cases. Like on the flood side, flood's such a unique product out there that most policyholders don't know what their flood policy covers. So that's another reason why we do these claims corners, is so that we can educate the adjuster more. So when they're out there talking to the policyholder, they can give them more guidance on what to do, and just little tidbits like this, understanding things about the HVAC and how things occur and why things happen, even on the property side, just makes that adjuster so much better at servicing that policyholder, basically giving them everything. Because, in a disaster, it's tough for people. Policyholders, they're looking for help. And the more information that the adjuster has, the field adjuster has, the inside adjuster has, the better we can educate that policyholder on what to do and what to find. I do have something, though. You were showing us that report and the things you recommend, especially on that one with the data plate and the R22, and you're like, and I know last year we talked about this. You're like, anybody says they got to replace it because this it's not true because we can. I think you were saying the R22 is now like they can reclaim it,
Yep.
stuff like that. So I was like, I would love to know, do y'all do like personal homeowners as well? Like if I called you and said, hey, this company wants to replace my unit, can you check it for me? And the reason I asked that, because I've had in the last like 4 years, I think every time I turn around, one of our units goes out. And immediately they're like, oh, it's got to be replaced. And now I'm looking at this going, man, I could have saved so much money just by having somebody that knows what they're doing look at it.
That's what he said.
I try to give some anecdotal stuff to help people out as well. Unfortunately, HVACi, just so we can stay objective and say we work specifically for insurance carriers and adjusters, we don't open it up to the general public, but you might happen to know somebody over here now that might be able to take a call for you and help you out. So
I like the way you're thinking.
just let me know.
He said
Appreciate that.
they are designed to be repaired.
They are
That's
designed to
one of
be
the
repaired.
things.
If you remember nothing else from what I say, think of your car, right? If you ding your bumper or the car is not running right or you get a flat tire, you fix it. Most cases, you don't go get a new car. Same thing should be with your HVAC equipment. You should be thinking at the component level, these things are designed to be repaired. All those vans driving around in your town, going from place to place, they're fixing HVAC equipment. They're installing some new systems too, but they're fixing them.
Every time they come to my house, they're replacing them. Whole
Right.
thing got to be replaced. Every unit in the house, like even their handler in the attic, absolutely. Of course, my wife, she's just in there going, oh, okay.
One of the I know from now on when I'm at home and the power goes out, I'm gonna be running around the house turning everything off.
Oh, absolutely.
Absolutely.
Yeah. Oh, I actually do that now.
Oh,
As soon as there's a storm in the area, it's like shut everything off.
Yep.
You
You guys may or may not have dealt with, so there might be some people on the line a couple years ago in Tulare, California, a car hit some poles, brought the wires down. They shut off the grid to fix it. They turned it back on. 1,400 homes had a surge event like that. StrikeCheck and HVACi helped with hundreds and hundreds of those claims.
Wow.
And that is a grid-tied surge event issue.
Yeah.
So unbelievable. It happens all the time.
Oh, yeah. I mean, we had something actually at our house not too long ago. We had a tornado just literally 100 yards from us touched down and then went across, and it knocked a bunch of power poles off down Rangeline Road and everything. And immediately I was like, turn everything off. As soon as they fix something, that power comes back on, we're going to have a problem. So
Yep.
we basically lived without power. We turned everything off, and when it actually came back on, we didn't know it.
You might want to leave one lamp on, right?
We didn't know it for a couple hours.
Yeah, you blow a lamp up, no big deal, right?
So what were y'all doing?
What else you have for me? Anything?
I'm also gonna go take my garden hose out there and rinse out the coils.
Be careful,
It's
but
not a
yes,
maintenance
you got to keep them clean.
policy,
That's
right?
part of your regular maintenance is keeping the coils clean. The filter is for the inside. That's why they have a filter so it doesn't get dirty to begin with. On the outside, you need to keep those. You need to keep them clean.
It goes back to, let me just comment on this as adjusters, where we want to try to find coverage for our policy.
Sure.
Right. But at the same time, it's impossible to be an expert in everything. Right. So relying on folks like you, I mean, there's just so much information and you had 30 minutes to go through all that.
That was quick.
Knowing all that, it's impossible to remember all that. So, my takeaway is they are designed to be repairable. We want to do right by the policyholder, but also by the, what the policy is enforced at the time of the loss too. So,
And there's several things that are turned in as lightning that are not lightning, and they could be misconstrued, or they might actually look like it. But unless you have somebody actually checking for that resistive heating or the acidic refrigerant or dirty coils, they might get actually move on through the process as lightning or surge when they're really not.
That's right.
And that's something that as an adjuster we should obviously be looking at more closely at, and not just letting a technician just push, hey, replacement, but look at it and go, okay, because a lot of times that's done, you're in a rush and they've got the policy holder and they're like, oh, we got to get this replaced. How much do I get? Then you look at it and go, well, we can just repair this and do this. And based on what I'm seeing, we may need to call out some money like you guys and say, let's do more thorough
An
analysis of
assessment.
this.
Give us a professional assessment, because lots of times, I know on the property side is we've got issues, but the adjuster, they're not the expert to go out there and see what's wrong with it. What's the cause of loss?
Right.
What's wrong with it? Have a technician give us their report.
I can't tell you what's
assessment.
wrong with it.
Right.
I mean, I couldn't tell you what's wrong with the unit.
Right.
And the statistics are just overwhelming. Again, didn't have a lot of time at the beginning. We're a very data-driven company. I think it's over $5,500 per HVAC claim for when it should have been repaired instead of replaced. So we call it accuracy.
Mhm.
So just think how much that is over the course of the entire industry over a year or whatever. It could be, between $500 million and $1 billion of accuracy out there. Just needing to be pay a little bit closer attention to. So
Right. Right.
it's a big deal.
I have a crazy question. You may know, you may not. So I did hear at one point that if you buy your unit out of Canada, it's like a third of what we pay for here in the United States. Is there any fact to that?
I don't want to, guess at that. I can do some research on that.
Okay. I just didn't know if being
I
in the industry, you
don't
may have
know
heard that. So, yeah, being in the industry. Multiple people told me that. They're like, yeah, we buy most of our units from Canada. And I'm like,
Really?
they're like, yeah, we get them for like $1,000. And, here you're paying $15,000. It's like, wow, okay. Just something crazy.
Yeah. I mean, just me personally, I think I'd be a little, if it sounds too good to be true, maybe it's not true,
Yeah.
or it's not the same product. It's
Well,
not like kind of quality, or maybe that had something to do with
Is that where you got all
the
four of your
currency
units
exchange
from?
at the time. I don't know, but
Yeah. Anyway, that was just being in this industry. I thought maybe that's something you had heard about, and I'm not going to go.
I have not heard that as being a widespread thing. No,
Selling.
if it was a huge widespread thing, I think we
Yeah.
would have heard much
Yeah.
more about that.
Maybe it's one of those like speakeasies that nobody knows about. You kind of keep it quiet, and then you're like, that's great.
That's right.
Yeah, I'm not going in the HVAC business by any chance. So, all right, David, do you have some more comments or any questions?
No, I'm good. I'm
And I think we looked here in the chat. Julie did not have any questions. So,
yeah.
I either did a good job or I went too fast. One of the two. So
no, I think you did a very good job.
Yes, I think you covered a lot of information.
Yeah.
Just want to thank you for being on, along with you and Brian, teaching us all these things today. We're
absolutely.
going to see you at the conference, right?
Hope to see everybody at the conference, and we're going to talk about some more stuff with storm damage to the units, wind and hail, and things like that. Talk about a whole nother thing about whether you can comb it, can't comb it,
Yeah.
all that sort of stuff. So we'll get into all that when we're down there at the conference.
Yeah, I'm
So
definitely
come and see
looking for
us.
that. And and that's one thing is if you've missed our, you come into our conference, those adjusters who are coming to our conference and clients are coming to our conference. If you missed any episodes about the HVAC, go back to some of our episodes on our YouTube channel. I always have it.
You struggle with that.
YouTube channel. I keep saying YouTube channel, which is our CNC Catastrophe National Claims channel, and watch some of these episodes before you come to our conference, because like the last one, like we talked about, was some of the components and the refrigerants and things like that, and how things cool and heat and what it all does and how it works. And I mean, so you get that information. Now you're getting this information. We talked about the StrikeCheck, and then when you come to the conference, you have additional information about hail and combing and other things that are just, you're building your knowledge base of something that a lot of us just really don't have no idea how it works. And now we're getting this information about how it works, so we can better educate those policyholders out there. So,
Right.
Absolutely.
Yeah, we look forward to seeing you in May.
Absolutely. I'm looking forward to coming down.
We're gonna have our next episode in 2 weeks, March 16th.
I guess.
Is that 2 weeks from now?
Sure.
Yeah. The topic is going to be fortified homes.
Okay. Sounds good.
Which is very interesting.
From
So
research to real world resilience.
yeah, we're going to have the experts come in there and talk about that. I have a fortified roof.
I do too.
I'm interested too.
And I think this is also another great topic to talk about, because where the market is going with fortified, and adjusters really need to know this. I mean, yeah, people, when you talk about fortified, it's the first thing we're strengthening a home to prevent it from being damaged from a hurricane or some type of peril, but at the same time, they still get damaged. You still have to know how to deal with them. and the cost to replace these is actually more.
Right.
So,
Yep.
Right.
so yeah. So Jay, if you can join us for next week, we'll definitely send you an invite. Hop on, and like everybody else for that's on today.
That'd be great.
We're gonna send out. We'll send out this information again, and
Thanks for everything, Jay, Brian. We appreciate
Absolutely.
it. What was the cost of that conference again?
Y'all have a great day, great week, and we'll see y'all in 2 weeks.
2 weeks.
Thanks, everybody.
See ya.
Thank you.
99.99.